Alrighty. Well, I wasn't really hoping for another snow day back to back, but here we are. Sadly, the show must go on. So, yeah, calculus, we have to learn something newish. And I know I didn't pass out the next note sheet because I wasn't expecting to go on, but on the Google Classroom, we're going to be going through, I have all the notes posted for the unit. So we're going to be going through 5.3. More specifically, we're going to skip the first two examples and come back to them later on. And hopefully this topic actually clarifies some of the kind of difficulties we were having with the local extrema and stuff from more specifically the last homework assignment 5.2, number 4, I think, with the little dip that goes constant, right? We're actually going to answer that question as to why that's not considered an extrema today. But first, yeah, on the Google form today, you're going to actually have 3 different questions to answer. One, because I'm kind of curious. Don't worry, only one math question. I know. Don't worry about that. But 2, I'm just kind of curious because most of you guys are seniors, and I'm interested to hear your guys' opinions on the questions I'll be asking later on. So firstly, let's talk about what the first derivative test actually implies. Now, I didn't write out the definition of the first derivative test because it goes all in on that, but the concept itself is pretty easy. Remember what a derivative is. A derivative, in general, just tells you the slope at any given point that you want. So when you do find the derivative, for example, let's actually just do example number 3. The f of x is equal to 2/3 x cubed minus x squared minus 4x plus 2. And it's going to help you to have the guided notes pulled up as we're going through this. That way my explanations can hopefully get a little bit clearer as to what she's going through. But let's first start by taking the derivative, right? It's just a straight power rule, right? So you got f prime of x is equal to, bring the 3 down, it cancels out with the third, so now it's just 2x squared, and then minus 2x, minus 4, the constant goes away. And what this is actually telling us now is any x value we plug in, it will give us the slope of that line at that very specific point. So now we're asking, or it's wanting us to find the increasing, decreasing intervals. And in order to do that, we need to set the derivative equal to 0. And why is that? Well, hopefully this is going to show you why that is. So just trust me on that. So now we got 2x squared minus 2x minus 4 equals 0. Divide by 2. So now you got 0 is x squared minus x minus 2. And I don't think it's a shocker we solve this by factoring. So here we go. We got 0 is equal to x minus 2, x plus 1. So you got the 2x values being 2, x is equal to positive 2, x is equal to negative 1. Now, let's take a moment just to think about what this is actually telling us. So here, if we were to actually graph this bad boy, it's a cubic. So it's going to look like a John Travolta, if you really think about it. So here, I'll draw a little sketch of what this might look like. So if you're to actually see this visually, then here it's telling us that perhaps if we had a John Travolta right at x equals 2, and we're actually going to be doing a lot of this thing called curve sketching later, then it might have well, actually, let's make the intervals, and I think we could sketch it based on that. So how do we make the intervals? Well, here, we actually want to make the intervals for the entire domain. We've done something like this last year, and we did a little bit of it this year, too. And actually, I'm going to write it over here so I can have more room, because forgot how small this chalkboard is, even though it's big. It's still rather small. Or actually, I don't know, I can do it right here. We're going to make 3 different intervals. First one being from negative infinity to negative 1. So the very first increasing interval there. And then we're going to be going from negative 1 to the next 0, so 2. And then we're going to be going from 2 to infinity. And the reason why is, well, we did this with polynomial solving, or inequality solving, right? And we're going to plug in a test value. Any value between negative infinity and negative 2. Let's pick -2. We plug in -2 here, right here, -2. Then you got a negative value times a negative value. So negative times negative, giving you a positive value. So then we have a positive. And what does that mean? Well, that means that your slope is going to be positive. So that means that your derivative is positive. So that means you're increasing. And the reason, well, let's just finish this off real quick. -1 and 2, plug in 0, negative times a positive gives you a negative. And here, if you remember the kind of trick we did way back when, plug in a number between 2 and infinity. Let's pick 3. 3 minus 2 is positive. 3 plus 1 is positive. So positive times a positive is a positive. So what this is actually giving us is a little bit of a way to actually graph this out. So here at -1, it's going to actually have a little hump right here. And it's going to be going from positive increasing. If you remember, this is a positive John Travolta because it's cubic. But this also clarifies it too, because it's positive. So reading left to right, it should be increasing. And right at 1, it's going to have this little hump there because or -1. But -1, your derivative is 0, meaning it's going to have a horizontal tangent. So the slope right there is 0. Similar thing here happening at 2. So right at 2, well, from -1 to 2, it should be going downward. So it should be decreasing all the way up until 2, right here. And then it's going to have a horizontal tangent. So right there, these little humps right here are always going to have a horizontal tangent, meaning your derivative is 0. And then it's going to be increasing from 2 to infinity. So this is actually called the first derivative test, is being able to graph this. And actually in 5.5, we actually have a formal section called graphing these, or graphing based on first and second derivatives. And 5.4 is a second derivative test, so there's actually more we can do with this and be more precise. But your first question is going to be a math question. It's going to be, if you have a trig function, so let's say positive and negative, or let's just take regular sign. So your first question, you have f of x equals sine of x. We know that the derivative of this is cosine of x. Take a look at the graph on Desmos or GeoGebra or anything like that. That's fine. But why does cosine of x being, or f prime being 0, what happens to sine at these values? So cosine of x being 0 is at, well, pi over 2. 3 pi over 2. 5 pi over 2. And so on and so forth. So your question is to answer at those values where your derivative is 0, what's going on with your graph of sine of x? So you can take a look at it graphically, or if you already know what it's going to be, then maybe you don't need to. But that's the question, question 1. All right. So now we'll do one more example, 5.3.4. So the next one on the next page. And it's going a step further. It's almost the exact same type of question. Actually, part A is the exact same type of question. So you got f of x being x to the 4th minus 8x squared plus 1 by increasing, decreasing intervals. And then determine the x values of a local extrema. So it's literally a direct consequence. But then it's also asking us if it's going to be a min or a max, too. And we'll explain what that means later on. So, or actually today, but yeah. So firstly, I don't think it's a shocker, just like before, find f prime. So, and actually I might just, erase this over here. If you need it, just go back to it later. Just have more room. And that way I can write bigger and more legibly. So, but yeah, so let's find f prime. So f prime is going to be, I'm more aggressive now. 4x cubed minus 16x. And just like before, we're going to be setting it equal to 0. And while we're at it, we can factor out the 4x. So then we got x squared minus 4. And then factoring it out. So now you got 4x, x plus 2, x minus 2. Cool. So now, just like before, let's make a table and set up our intervals. So here, let's see if I can find a better color. Does blue show up? Yeah, sure, it does. So our intervals are going to be negative infinity to your very first one, to your very first 0. So the 0 is being x equals 0 right here for that 4x. X equals negative 2, and x equals 2. So negative infinity to negative 2. And then negative 2 to 0. And then 0 to 2. And then 2 to infinity. And we're going to do the sign checks. So here, if we're going to plug in a value between negative infinity to negative 2, just take negative 3. Then you got 4 times negative 3 is a negative value. And then negative 3 plus 2 is a negative value. And then negative 3 minus 2 is negative. So negative times a negative times a negative is still negative. And actually, this makes sense, because from the original function, the x to the 4th, we already know the basic shape is a little w thing. So, and if you think about the graph, it's starting by going down. So this makes perfect sense that the slope is actually going to be negative, because it's decreasing. And if you remember the tricks, which there is a trick to this, because it almost flip-flops every single time. Negative 2 to 0 is pick negative 1. Got negative times positive times a negative. Negative times positive times a negative is positive. 0 to 2. Pick a number, let's pick 1. You have a positive times a negative is a negative. And then from 2 to infinity. So here, let's pick 3. Positive times positive times positive is positive. So our increasing intervals, are where the derivatives are positive. So negative 2 to 0, and then union to infinity. And decreasing is the ones where your derivative is negative. So negative infinity to negative 2, union 0 to 2. Okay. And then the last follow-up question, so letter B, but before that, let's go for question number 2. So part of my job as a teacher is to teach you the math, of course, but also part of the job as being a teacher is teach you some life skills. So a lot of y'all are about to go off to college, and you're going to realize that a lot of the professors aren't really going to be as caring and understanding as some of the teachers you have at Moberly. And actually, you do have a lot of stacked teachers at Moberly. Not tooting my own horn, I'm one of them. So, and I've lived a lot, and I've had a lot of experience under my belt just beyond academia or school. So if there's one skill that you would like me to teach you to help prepare you for college beyond math, right? What would that skill be? So that's the question number 2. So question number 2. If so reiterating the question number 2, if there's one skill that you wanted to learn from me as an individual, whether it be like organization, responsibility, leadership, what would that skill be? I'm curious to know your thoughts. Okay, letter B. Determine the local or the x values of the local extrema and determine if they're min or max. Well, so the x values of the local extrema are where your derivatives are equal to 0. So you have x equals 0, x equals negative 2, and x equals 2. And usually the endpoints, but here they don't give you endpoints, and we're just assuming it's negative infinity to positive infinity, so we can't really have infinity as a critical value. But now it's asking, what type of extrema is it? Well, if you really think about it, right, what the derivative is telling you, from negative infinity to negative 2, you're decreasing. But then from negative 2 to 0, you're going to be increasing. So if you think about it visually, you are actually getting a minimum. because it's going to be from increasing to decreasing. And actually, straight up, in my calc class, AP Calc in high school, during the test for this, you just see all these students just doing the little roller coaster with their hands during the test. And I thought it was really funny. And it works. I promise you it works. If you do the hand thing from increasing to decreasing, it's going to help you. And she does it on the table in the guided notes. And it's a little bit more confusing that way, but doing it physically is actually going to help you out how to remember and whether or not, and help you determine whether it's going to be a local min or max. So x equaling -2 at that very specific point right there, from increasing to decreasing to increasing, we're actually going to have a local / relative, if they're the same, min at x equals -2. So, and then local max. And then from increasing to decreasing, so increasing to decreasing, that's going to give you a local min. If you think of it like this, increasing to decreasing, it makes perfect sense. And that's going to be right from increasing to decreasing, 0. So x equaling 0. So, and then from decreasing to increasing, once again, you're going to have a local min. And that's the easiest way to kind of think about it. So, and the justification formally is your f prime changes from positive to negative. Now that's the actual formal one that she's got written down there. And it's good to know that kind of vernacular, because hard part about this math, like math itself is easy. It's just figuring out what to do and how to write it, right? Math, upper level math is a language, and you actually have to learn how to read and write the language. So most of the time, like doing the calculations and getting the answer itself is easy, the actual math part. But the hardest part about it is figuring out what it's even asking. And that goes on for any type of subject that you're getting into. So, yeah. Now, question, actually, I'm not going to give you question 3. So there's only going to be 2 questions. So, all right, well, I hope you guys are hanging in there. Email me if you have any questions, comments, or concerns. When we get back, we'll finish up 5.3. Hopefully that's going to be on Thursday. And then you'll have a homework assignment. But yeah, no, hang in there. Let me know if you have any questions, and stay chilling.